In this video, we are going to learn about gravity and free fall. What is free fall? What is gravity? What is its value? And what is the relationship between gravity and radius of Earth, and the difference between mass and weight? All these important concepts we are going to discuss now in this video. Okay, these are the important points that I have already told you. Now, let's learn about free fall. What is free fall? Whenever something is falling from a certain height, of course we know that air hindrance is the frictional force exerted by the air. We know that frictional force is that kind of force that is opposing the motion of an object. If no other influential forces like frictional forces are there, okay, no other force, only this kind of gravitational force is there, at that time we can tell that the object is they are in free fall. That is, whenever objects fall towards the earth under the gravitational force alone, we say that the objects are in free fall. So whenever we consider free fall, no other force should be there in its path, no hindrance, no barrier should be there, only it will be coming down with the influence of gravitational force. Okay, while falling, there is no change in the direction of motion of the objects. We know that it is moving down, isn't it? The object is moving down, so it is not changing its direction. It is coming in the same direction. But what happens due to the Earth's attraction, there will be a change in the magnitude of the velocity. Magnitude of the velocity means the value of the velocity. The value of the velocity will change because it is under the influence of the attraction of the Earth. And you have already studied that change in velocity creates acceleration. You remember? Yes. So change in velocity creates acceleration. So an acceleration is produced in the body by the Earth. Okay. And another important fact is that the force which is exerted by this, the gravitational force, isn't it? And that depends upon mass. F is equal to ma, so that is depending upon two quantities, mass and acceleration. But mass is not playing an important role in this free fall. The objects of different masses will be reaching on the earth at the same time. Okay, if they are dropping from the same height, object of same shape and all, they will be moving down and they will be reaching on the earth together only, or simultaneously only they will be reaching on the earth, because mass is not having any influence on it. Only this value of g, acceleration, that is produced by this earth's attraction, that determines the acceleration or speed of the object, and it will be, or they will be falling. All the objects will be falling and reaching on the earth at the same time. That is what we call the free fall. And if you are considering, of course, the influence of air, then we know that what happens, air will be resisting. So if the mass is higher, means it will have to exert less amount of what we call this force in order to overcome this frictional force by the air, and it will be reaching faster. And in the case of lightweight objects, they will be taking a little bit time to overcome the frictional force exerted by the air. So that is not coming in the case of free fall. In the case of free fall, all the objects will be reaching on the earth at the same time, irrespective of their masses. Yes, next that we are going to learn about gravity. In the previous session, that is when we were talking about free fall, we learned that whenever an object is falling freely towards the earth, it does not change its direction, but it changes its velocity. A velocity change will be taking place. And we know that change in velocity is known as acceleration. So an acceleration will be developing in the body which is falling freely towards the earth. And since this acceleration is produced by the gravitational force of the earth, it is known as acceleration due to gravity. That means acceleration is produced because of the gravitational force of the earth, and it is denoted by small g. the unit of g is same as that of acceleration, that is meter per second square. And I hope you remember the value of small g, 9.8 meter per second square. So here we discussed that free falling objects, there will not be any change in direction but change in velocity. Due to change in velocity, an acceleration will be produced, and this acceleration is produced by the gravitational force of Earth. So let's derive the expression for small g. We know two different kinds of expression for f. F is equal to mg and f is equal to gmm by g square. F is equal to mg. That is the first expression. And second expression is that f is equal to gmm by g square. So both are f, so we can equate mg is equal to gmm by d square. That is done here. Mg is equal to gmm by d square. So small m on both the sides of the equal, so that can be cancelled, and the remaining is g is equal to gm by d square. So this is the equation, or this is the formula to find out the value of g. Okay, g is equal to gm by d square. Now if the body is placed at the surface, the body is, okay, before that we can talk about this also. Acceleration due to gravity, g, does not depend on the mass of the body. It will be the same for all bodies falling to the earth, because you can look at the equation for g, gm by d square. Can you find out small m anywhere? Anywhere can you find out small m? No, you cannot. So small m we have already cancelled here. So this small m does not play a role in finding out the value of g. So acceleration due to gravity does not depend upon the mass of the body. So whatever the mass of the body which is falling from a certain height, all the object will be reaching the earth at the same time only, whether it is an elephant, whether it is a mouse, whatever, who are maybe falling from the same height, they will be reaching on the floor at the same time only, if we are considering only the gravitational pull of the earth. Okay, that is very, very important. We have to consider only gravitational pull of the earth, then all the objects will be reaching the earth on the same time, irrespective of their masses. Now if the object is at the surface of the earth, if the object is standing at the surface of the earth, we can consider, we can change this d by what? Capital R. R is the radius of earth, that is g is equal to, what was the formula of g? G is equal to g m divided by d square. So instead of d we can use r if the object is on the surface of the earth. If the object is on the surface of the earth, anywhere on the surface of the earth, we can replace d by r. So the formula will be g is equal to gm by r square. So whenever we consider this r, there is an importance. That's why it is told that the value of g is slightly different in different places. It is having an average value of 9.8 meter per second square. I hope you remember the value of g, that is 9.8 meter per second square. That is the average value between the equator and the poles, because you know that whenever you look at this picture, the radius is slightly different. In pole region, in this region, the radius is slightly smaller than the radius at the equator. Got it? Because it is not a perfect sphere. The earth is not a perfect sphere. So the radius increases from the poles to the equator. While you are moving from here to here, the radius increases. That is, from moving from poles to equator, the radius increases. The value of g becomes greater at the poles, because as r increases, g decreases. R decreases, g increases, because they are inversely proportional. So the value of r increases means g will be having a slightly smaller value. So the equator, the radius is having higher value, so g will be having smaller value. At the poles, r is having smaller value, so g will be having greater value because they are inversely proportional. Okay, the next one, calculation of the value of g. How we can calculate the value of g? Using the same equation, g is equal to gm divided by r square. We know the value of capital G, 6.7 into 10 raised to minus 11 Newton meter square kilogram raised to minus 2 into, what is the mass of earth? 6 into 10 raised to 24 kilogram divided by the radius of earth, 6.4 into 10 raised to 6 meter, the whole square. So after doing the calculations, after making it short, we will get 9.8 meter per second square. Okay, next one, the relationship between mass and weight. Mass of an object is the measure of its inertia that we studied in the chapter motion, inertia, isn't it? Mass, if higher the mass, higher the inertia. Yes, smaller the mass, lower the value of inertia. So mass is actually, it's the measure of its inertia. Greater the mass, the greater is the inertia. The mass of an object is constant and it does not change from place to place. That is very, very important point. Mass will remain constant always. Wherever we go, whether we are going to the moon or any other planet, our mass will be same only. Mass of a body is the amount of matter contained in it. We have already studied what is matter, isn't it? So, amount of matter contained in a particular object, that is known as mass of that particular object. So it is not going to change because the matter, the particular object will be having the same amount of matter wherever it goes. But when we considering the weight will be changing, isn't it? Because weight is equal to W is equal to mg. That is the formula for finding out the weight, and we know that g will be changing. G is having different values at different places. So G will be changing, so W also will be changing. So mass is not a changeable one, it is constant, but W, the weight, will be changing from place to place. The weight of an object is the force with which it is attracted towards the earth or towards any planet or any place, isn't it? Suppose we are going to the moon, the force at which it is attracted towards the moon, that is known as the weight of the object in the moon. If we are considering about earth, the weight of the object is the force with which it is attracted towards the earth. So force is equal to ma. So mg, whenever we are considering about the gravitational force of the earth, we can change A by G, so W is equal to mg. Its value depends on the value of G, so it changes from place to place. So here I have given the picture of two different devices. One is common balance and the other one is spring balance. Both the equipments, both the devices are very much familiar to you. Mass is measured using common balance, whereas spring balance is used to measure the weight. The next we are going to discuss weight of an object on the moon. Weight of the object on the moon. How we can derive an expression for weight of object on the moon? W is equal to gmm by r square. We can use the same formula. Here M stands for moon, gmm divided by rm the square, that is radius of moon square. And same time we can use the same formula to find out the weight of the object on the earth, that is We, gmm divided by r square. And we can substitute the values of mass and radius of both moon and earth on different equations, and finally we will get two different values like 2.431 into 10 raised to 10 gm, and We is equal to 1.474 into 10 raised to 11 gm. And we are going to find out the ratio of Wm and We. That is, the ratio is equal to W. This one is the ratio. Wm m divided by we is equal to, just divide these two values, we will get 0.165, that is equal to 1 by 6. So weight of object on the moon, Wm, is equal to 1 by 6. We can keep this 1 by 6 here, and we can take this weight of the object on the earth to this side, that is We. Weight of object on the moon is equal to 1 by 6 times the weight of object on the earth. So on earth we will be having a higher weight, and when we go to moon we will be having only 1 by 6 of the weight. Okay, so suppose we are having 30 kilogram weight on the earth, 30 kilogram weight on the earth. When we go to moon, okay, when that person goes to moon, what happens to the weight? That will become 30 into 1 by 6. So when he reaches moon, his value, his weight will become 1 by 6 of 30, that is only 5 kilogram. Only 5 kilogram weight he will be experiencing when he reaches the moon. I hope you understood this. So suppose if you like this video, you can like the video, you can share the video with your friends, and do good comments also.